All right, so here we are with right triangles. Our first section is right triangles. Area of a triangle is base times height times half, or base times height divided by 2. So when we're working with right triangles, we're always looking for those lines that make the box, make the right angle. So here is 3 examples. Right triangle here. So there's your base and height. In this situation, you would have to use Pythagorean triples or Pythagorean theorem. This piece right here is useless. The hypo is not going to help us, so you need to use Pythagorean theorem. All right, on the second one here, we have our right triangle. You should see automatically when you see the 45 that you are going to use it, and you're going to use the rules for a 45, 45, 90 triangle. So in this case, if that hypo's 12, use this for units, so don't worry about that. So we'll divide by 2, give it a radical 2, divide by 2, give it a radical 2, and you'll be multiplying those two together. And when it's all said and done, you will divide it by 2. So there's that. All right, on here we have a 30, 60, 90. We'll have to use that hypo. So if we go to the little leg, it's half. Then we go to the big leg, it's 5 radical 3. And once again, our base and height is little leg and big leg. All right, so how do we find the area if it's a non-right? Okay, so find the area of a triangle whose sides are 15, 15, and 18. First of all, you got to recognize this as isosceles. Okay, so always put the biggest side on the bottom. So here is 18. Here is 15. Of course, the two legs are equal. So what you'll do is you'll bring your altitude down and you create 2 equal right angles. These are not 30s, 60, 90s. Just because it's isosceles, we do not automatically put a 60 in those corners. It's not equilateral. What you do is you got to recognize that this 8's cut in half, and use Pythagorean theorem again to find that height, or recognize your Pythagorean triples. Remember though, the base is still 18, not 9. It's 18. That's a big mistake a lot of students make. Now on the equilateral, you get to do what we used to do in special right triangles. You got your 60, all sides are 16. So there are your sides. You bring down old school special right triangles. That 8 or that 16 becomes an 8. This is a little leg, this is a big leg, and once again you have your base and height. Don't forget to divide by 2 when you multiply. Alright, so you try a couple. Alright, so try these two. Remember, you pause it, and then I'll go over the answer. Alright, so hopefully you paused it, gave this a try. So hopefully that's not too bad of an example. It gives you your base, your height. All you got to do is put it in a formula. So I hope that's okay. Alright, so here is one of our special right triangles. So you would have to use the rules. For little leg is half, big leg is 8 radical 3, and this would be your equation. This will come out to be 32 radical 3. Remember, you got to divide by 2. So that's 8 times 8, 64. Divide that by 2, and then put the radical 3 on the end. All right, so pause it. Try these two. All right, find isosceles of find the area of isosceles triangle with legs of 5 and 8. Okay, so here is what I'm drawing. Oh, it's gone. Let's see if this one has it. There it is. So when you cut that, when you bring that altitude down, that 8 becomes 2 4s. But remember, our base is still 8. And you got to use Pythagorean theorem, or hopefully you guys saw that it's a Pythagorean triple. So you're going to multiply 8 times 3 divided by 2. And now our last one, equilateral triangle with perimeter 36. Perimeter 36 means they all add up to 36, and that's 3 12s. You get to put 60s in the corner. So there's what happens there. And then you do your 30, 60, 90 rules, and you have a base of 12, a height of 6 radical 3, multiply them and cut them in half. There's the triangle.